Hey guys, welcome back to AlgoYogi. We are doing binary search series and we are about to wrap it up. We have last 4 problems left, medium level. I don't have any hard level added yet, but I might add later. Okay, so let's go to our next problem, which is find first and last position of an element in a sorted array. Okay, I mean, this is enough to basically understand the problem. Given an array of integers, arrays nums, sorted in non-decreasing order, that means numbers are non-decreasing, that means they're increasing but not strictly increasing, and that's the core of this problem. Find the starting and ending position of a given target value, and when are those values going to be different, this starting and ending, when they have duplicate values, right? So this is a sorted array given to us. Target here is 8. If it has unique values, then the starting and ending position, first and last position of 8 would be just 1 if it wasn't repeating. But since now we have duplicate copies of these elements, we're gonna have these different indexes for first and last index of a particular value. All right, so that's what we need to return, and we're gonna do it like really easy, really easy, because like right now I can think of just trying to find the first and then trying to find the last position of these elements, and we're gonna have two binary search functions, basically first searching for the left position and then another searching for the right position. Whenever you are able to find an element with the binary search. Okay, so let's do that. Let's understand actually how we're going to approach it. So first thing first, what I'm going to do is, since this is already sorted, so we know we're going to apply binary search here. It's just very similar to regular binary search, but it's just we need to find 8's first position, since that is the target, and 8's last position. So how about I have two binary search functions to find the, so bs first target. So this is the target we are going to basically find out. So we'll send it nums or lr or whatsoever. This will actually give us the left index of our target. So if I write down the indexes here, this function should return me 3, and this function bs last should return me 4. And how are they going to do it? Is by when we are writing this particular function, what we will make sure is that whenever we are able to, it will be a regular binary search algorithm, which is basically having while left is less than or equal to our right pointers, mid calculation, which is r plus l, and this is small r, divided by 2. Now if this time, if m, and whenever I'm just saying m, I mean nums m is equals to our target, that means we will have our result, and we will assign that to our result. So result would be that m, but since we are trying to find the leftest possible, in this case the leftest possible valid index that has the value as target, so what I'll do is I will still move my right pointer to mid -1. all right, and then I'll have another elif case, which will be if my medium, which the middle element is basically smaller than my target, that means I need to go to the right side of the array to look for it. So I'll move my left pointer to mid +1, and there is one more case, that is, I did not find m is greater than. So m is either equal, m is either smaller, or m is either greater. So else case, we don't have to mention the condition. We'll just simply move our right pointer to m minus 1, which means we gonna start looking in the right side. Here as well, we are doing the same thing, but we know we found the target where we're trying to get the leftest possible valid index for that value. Okay, so this will be the code. This will be the code for finding the first, and for finding the last element, last index of the target would be the same code, just little minor tweak, and that is, this time whenever our target is equal, instead of taking the right pointer to basically mid minus 1, we'll take in this case, we'll take left pointer to mid plus 1. Okay, I think this is pretty clear now, that we're going to have these two functions. First is binary search first and binary search last, and just call both of them and then return the answer as how it was asked to us, which was, if you see over here, if target is not found, we're going to return -1, -1, but this is the format we will be returning the answer as well. Okay, I think now we can just code up our solution. So as I said, let's have two inner nested helper function. First is bs first, and are we going to send in anything here? Honestly, we don't really need to. We can assign everything right here, but we could send 0 and so left and right as arguments, and finding that would be basically, while left is smaller than equals to right, calculate the mid would be basically left plus right divided by 2. Then let's check if nums m equals to target. That means we forgot to basically have result as -1, and then if we found the target, that means this is my possible answer, so I'll just basically assign that to my result. So I'll assign mid to my result, but now we're looking for the first element, basically the leftist element, leftist index for that target, which we just found. So there might be another duplicate copy of that element that exists in the left side. So I'll just move my right pointer to mid -1, and then I'll have elif case, which is basically if nums at mid, if the middle element that I just found, if it is greater than target, or let's say this is smaller than target, to make things look a little nicer here, because this time I'll be moving my left pointer to basically mid +1. All right, and then the else case would be basically moving a right pointer. The same thing is, just since we found the element here, we want to store the answer. Now we didn't find it, so we're going to look in the next half, because the first half, because the element, the mid element that we just found is greater than the target. So we'll bring our right pointer to mid -1. Otherwise, we come out of this loop because it will fail at some place. Either we found it or we didn't find it. We're going to return this anyway. Okay, let's compact the solution a little so that we're able to write and see the same function, but for the last index. Okay, last, and I'm gonna call it index as well, so that it makes more sense. Okay, bs first index, bs last index, same thing whenever you found it. So instead of placing the right pointer, as we understood in the conceptual part, instead of placing the right pointer, we'll place the left pointer to mid +1. Rest everything will remain same. Rest everything remains same, because at the end of the day, we will be assigning the index to our result whenever we found the target, right? And then we are choosing the next scope to find the last index of that element wherever it exists. Although some people might try to think that how about if you found the target, how about just do a linear search on both sides and try to get to those two ends? But see, the input could be really long, and the value could be just same for a very between these really long index range. So it will end up becoming a solution of big of n time complexity rather than big of log n. Okay, so now let's just call our these two functions and just return them. Okay, so what I'll do, I'll just return these two functions and bs first, or rather than that, I think a better way would be calling it like this. So first is 0 and len nums -1. We want to send in the valid index, and then same thing for the last. Let's have this function, calling it over here, sending in the same index range, left and right pointers, nums -1. Okay, so now we have first and last indexes. Let's return them, and remember, these two will return -1 if they didn't find if these two functions didn't find any target. Okay, either they find, or if it's just one copy, they both return the same index. If they don't, then they both return the same index, which is -1. And if they have multiple copies, this goes to the left side, this goes to the right side, right? And then they just return those valid indexes. Okay, so I'm gonna zoom out and let's try to run it on our example cases, and I really hope it doesn't create any problem. It doesn't, and let's submit it. All right, once again, you can have a nice look. Or before you just see this solution, I would try to write it myself, because it's just this particular line that changes our binary, not regular binary search. Otherwise, if you take this line from both of these nested functions, it's just a regular binary search. So let's go back to AlgoYogi, mark this problem solved, and see you guys later in the next problem. Until then, bye bye.